Okay, we're going to use example 8.3 from your textbook. And here we have an insurance company, okay, and that has a business objective of reducing the amount of time it takes to approve applications for life insurance. So they want to find out what's actually happening right now. So they took a random sample of 27 approved policies from during a period of 1 month. Okay, and then looked at how long did it take for each of those approved policies to get approved from the time the application was made to the time when it was approved. Okay? And the 27 observations are given here, and these times are in days. Okay, now we want to develop a confidence interval for the average time taken to approve policies. Okay, so here we'll go to Excel. So here are the times for the 27 applications. So we start with defining what is X, what is mu, and what is sigma. And we need that to put context to the problem itself. So X here is the total processing time in days to approve applications for life insurance. So mu is the average processing time. So the average processing time. And of course, we don't know what that average is. We want to get more information about that. Sigma is the standard deviation of the processing time, and we don't know that value either. Okay, so we have to rely on the sample. So here is the sample. So let's collect the sample information. Now we're going to compute the sample values ourselves. Okay, so sample size is what? Count. Okay, and X bar, the average, is the average of the times. Okay, and then the standard deviation, make sure that you use stdev.s, that is for the sample. Okay. Now, are there any assumptions that are required here? Well, the sample size is slightly short of the threshold that we have for 30. Okay, 27 being close to 30 is, you're probably okay, but still we have to be very careful. So we need to assume that the population follows normal distribution, which means that you have to verify that. So we can do a box plot to see whether the whiskers are about the same length and the median is at the center of the IQ or the interquartile range. And then maybe you can do a histogram to see whether it has a nice symmetric distribution. And the normal plot, the QQ plot from StatCrunch, we went over these concepts in chapter 6. So we have to assume that the population is normal, follows normal distribution. Now we want 95% confidence interval. So alpha is 1 minus that. Degrees of freedom is n minus 1. So for 95%, the upper tail area is 2.5 or 0.025, and the cumulative is 0.975, 97.5%. So our T sub alpha over 2, degrees of freedom of 26, is going to be, let's go to the T table. Okay, here is the T table, and once again we want 0.975 for cumulative or 0.025 for the tail, and 26 is the degrees of freedom. So 2.0555 is the T value. The margin of error then is T times the standard error. We need the standard error. So standard error is S over square root of n. Then we can go T times S over square root of n. That's our margin of error. and then X bar minus margin of error and X bar plus margin of error will give you the upper and the lower limits for the confidence interval. Okay. Now if you want to get the t-table value using Excel function, okay, Excel has t.inv. So inv functions are the table functions. So there are two of them here, t.inv and then t.inv.2t, and then you see that there is just simply tinv. That's your legacy function. You don't want the legacy function. You don't use the legacy function. If you use legacy function, I'll deduct points. So you need to use t.inv. Okay, now we can use 2t. When you use 2t, okay, so you have to understand how the table is organized so you read the table properly, and similarly you have to understand how the function works so you use the function properly. So in 2t function, two-tail, 2t stands for two-tail, so t.inv.2t, you provide the alpha value for both the tails combined. So you don't need to divide this by 2. So alpha, the entire alpha, and then of course you need to provide the degrees of freedom. So t.inv.2t gives you the two-tailed t-table value, okay, which is exactly the same as before. Okay, and then the margin of error is t times the standard error, and then mean minus margin of error is the lower limit, and then mean plus margin of error is the upper limit for the range. Obviously it is this same limit because the Excel function and the t-table function are very close. Now the interpretation is exactly like what we have done previously, which is that we are now 95% confident that the time taken for an application to be approved is, the average time is between 33.89 and 53.89 days.